Hello children, welcome to Rectilinear figures part 3. In part 2 I have already explained the different types of polynomials, kite, trapezium, isosceles trapezium, parallelogram, rectangle, rhombus and square. And I gave all the properties of those polynomials. Also I gave a special diagram showing the relation among parallelogram, rectangle, rhombus and square. And this part will be based on theorems. Okay, there are many theorems in this chapter. You have to understand and remember all the theorems. Okay, so let us start from theorem number 1. It is the most important theorem of this chapter. Okay, theorem number 1 states that if one pair of opposite sides, okay, if one pair of opposite sides of a quadrilateral are parallel and equal. So remember this, parallel and equal. Okay, if one pair of opposite sides of quadrilateral are parallel and equal, it is a parallelogram. Okay, what is the actual definition of parallelogram? It is a quadrilateral in which opposite sides are parallel to each other. But this is a theorem using which we can prove that a given quadrilateral is a parallelogram. What is the theorem? If one pair of opposite sides are parallel and equal, nothing will be given about the other two sides or the other pair. Simply one pair of opposite sides will be parallel and equal, then it will be a parallelogram. So let us draw. Satisfying this theorem condition. A, B, C, D equal and parallel. Okay, so AB and BC are parallel and equal to each other, and we are going to prove that it is a parallelogram. Okay, so let us see how to prove this. We will use congruency here. Okay, I have already written in part 1 that this chapter is one of the most important and the biggest chapters of class 9, and there will be extensive use of congruency here. Okay, so we will use congruency. Given, what is given? AB parallel to BC and AB is equal to BC. This is given. To prove ABCD is a parallelogram. Okay, ABCD is a parallelogram. This we are going to prove. We need construction here, or directly we can go to proof. Construction we can do in the proof section also. Okay, now let us go to proof. Join either AC or BD. So let us join AC. Okay, join AC. You can use dotted line. Okay, I cannot draw dotted line here, so directly I am joining AC. Join AC. Okay, now I am going to prove congruency between these two. Okay, in triangle ABC and triangle ADC. Okay, we'll try to put congruency. You can see AB CD. Okay, one side we got. Then AC is common. Two sides we got. We cannot say BC equal AD. Nothing has been given. Okay, but we can say angle BAC equal angle BC, because alternate angles, these two are parallel, so these two angles will be equal. So SAS postulate, you can see side, angle, side. Okay, SAS postulate. So we start from side. AB is equal to BC, given angle BAC is equal to angle BCA, alternate angles. Then AC is equal to AC, which is common. Do not forget to write the regions like this in a bracket. Okay. So side angle side, angle ABC will be congruent to. While finding the order, I advise you not to look at the diagram, but look at this two triangles which you have written. Okay, you can get the order from here in a better way than this. If you have the angle, then first target angles I told in congruency. Okay, so AC, angle A, angle C, their position should be same. A first, so C first. Okay, now we do not have any other angle, so now we are bound to target sides. So let us go for the sides. AB and BC are equal, that means they are corresponding sides. So their opposite vertices will be corresponding vertices. So which are the opposite vertices? No need to look at the diagram. Okay, AB opposite is C, you can see. DC opposite is A. C corresponds to A. Okay, C and A are corresponding vertices. C is in third position, A should be in third position. Okay, so which is the remaining vertex out of ADC? C and A are over, so remaining is D. Only option is D. So triangle ABC is congruent to triangle CDA. This is by SAS postulate. Okay, and given the same order, when I in part 2 when I gave the property of parallelogram that each diagonal bisects the parallelogram. Okay, I have given this order. Okay, so ABC congruent to CDA. After this we can say angle BCA means 231. Okay, is equal to again 231 angle BAC. How? CPC, corresponding parts of congruent triangles. So BCA means this angle, okay, and BAC means this angle. Okay, so these two angles are equal. These two are already equal. Okay, this we are using congruency, but we got now this angle and this angle are equal. Means x then x. But you can see they are alternate angles. They are forming Z set like this. Okay, they are forming Z set, but they are alternate angles. That means AD must be parallel to BC. Okay, so you can write AD parallel to BC. Why? Because alternate angles are equal. When lines are parallel, alternate angles are equal. Okay. Conversely, when alternate angles are equal, lines will be parallel. Okay. This we have studied in lower class, in maybe class 6. Okay. So AD parallel to BC. So now what we got? AD is parallel to BC. Now in the question it was given that, means from the beginning it was given that AB is parallel to BC. Now we got AD is also parallel to BC. That means the opposite sides are parallel to each other. So it is a parallelogram. Okay. So now we can say ABCD is a parallelogram. Okay. Hence proved. So after this part you have to write ABCD is a parallelogram. How? Because opposite sides are parallel. Okay. So this theorem we can use to prove a quadrilateral is a parallelogram. Okay. So this is one method how to prove that a quadrilateral is a parallelogram. We can have different methods. One by one I will go to different methods. Okay. For theorems. This is theorem number 1, which is the most important theorem of this chapter. Okay. Next is theorem number 2. Theorem number 2, again based on parallelogram. First we will complete all the theorems based on parallelogram. Then we will move to rectangle. Then we will move to rhombus. Then we will move to square. Okay. Theorem number 2. Again we will go for sides. Okay. Theorem number 2. If opposite sides are equal, so the opposite sides of a quadrilateral I had forgotten this. Okay. If opposite sides of a quadrilateral are equal, it is a parallelogram. Okay. This is another way to prove that figure is a quadrilateral is a parallelogram. So let us draw a quadrilateral in which opposite sides will be equal. A, B, C, D. AD equal to DC, as you can see, it is given. Okay. AD is equal to DC. This is also given. We have to prove that it is a parallelogram. Given AB is equal to DC and AD is equal to BC. Opposite sides are equal given. We will prove that it is a parallelogram. To prove ABCD is a parallelogram. Now let us go to proof. Again we need construction. So let us join. We can join AC or we can join BD. Last time we have joined AC, so let us join BD this time. Join BD using dotted line. Okay. But I am drawing continuous line. Let us join BD. Now we will put congruency between these two triangles. Okay, you can see AB equal to DC, one side, AD equal to BC, another side, two sides, BD is common, third side. So SSS postulate. Okay, we can prove congruency between these two triangles using SSS postulate. So in triangle ABD and triangle BCD, okay, AB equal to DC. This is given here. Then AD is equal to BC. This was also given. Then BD is equal to BD. Common. These two are given. Okay, these two are given and this is common. So triangle ABD is congruent to triangle. Now we can get the order. Do not look at the diagram. Look at here to get the order. Okay. We don't have any angle, so we are bound to target sides. Okay. So triangle ABD is congruent to, take any two sides, AB and AC. They are corresponding sides, so their opposite vertices will be corresponding vertices. Which vertex is opposite to AB? D. Which vertex is opposite to DC? B. So D corresponds to B. D corresponds to B. Their position should be same. D last, so B last. Okay. Next, AD and BC. AD opposite is B. Okay, as you can see, BC opposite is D. So B corresponds to D. So their positions should be same. B is in middle. D should be in middle. So the last option is D over B over. So C remain. Okay. So C D B. This is S possible. You should not commit any mistake in the order. If your order is wrong, then everything will be wrong. I have told this in congruency. Okay. So this is the correct order. After this, we can say angle ABD 1, 2, 3. ABD means 1, 2, 3. Here also 1, 2, 3. Angle CDB, CPCT, corresponding parts of congruent triangles. So let us see which two angles are this. Angle ABD means this angle. Angle CDB means this angle. So these two angles are equal. But you can see they are forming Z shape. Okay, Z shape. That means AB must be parallel to DC. AB must be parallel to. So this implies that AB must be parallel to DC. How? Because alternate angles, these two alternate angles, okay? These two alternate angles are equal. Okay, when alternate angles are equal, the lines are parallel. So AB is parallel to DC. Now we can use theorem number 1. So look at the figure ABCD. AB is equal to DC. This is given from the beginning, and just now we got that AB is parallel to DC. AB is parallel to DC. So one pair of opposite sides of this quadrilateral are parallel and equal. So it is a parallelogram. Okay. So now we can write ABCD is a parallelogram. Why? Because one pair of opposite sides are parallel and equal. Okay, so it is a parallelogram. So this is the second method to prove that quadrilateral is a parallelogram. First method is definition method. Prove that opposite sides are parallel. Second is theorem number 1. Prove that one pair of opposite sides are parallel and equal. Third method is theorem number 2. Means prove that opposite sides are equal. We have one more method or one more theorem for parallelogram. This is theorem number 2, theorem number 3. Theorem number 3. Again related to parallelogram. Now we will see angles. So we will take angles, okay? If opposite angles of a quadrilateral are equal, it is a parallelogram. Okay, it is a parallelogram. You have to understand and memorize all the theorems. Okay. draw a quadrilateral in which opposite angles are equal. Okay. A, B, C, D. Angle A equal angle C according to the theorem. Means what is given? Opposite angles are equal. Angle B is equal to angle D. Okay, this is given. We will prove that this is a parallelogram. So given angle A is equal to angle C and angle B is equal to angle D. To prove ABCD is a parallelogram, this we are going to prove. Proof. We don't need any construction here. Okay. Angle A is equal to angle C. This is given. Let us take x. Okay. Suppose this is x. X. Next is given. Angle B is equal to angle D. This is also given. Let this be y. Okay. Let this be y. Y. Next, here we can write. Okay. Angle A plus angle B. What should be angle A plus angle B? Look at the diagram. Don't look at x and y. Simply look at the diagram. Oh, sorry. Let us add all the angles. Okay. Let us add all the angles. Angle A plus angle B plus angle C plus angle D. Sum of the interangles of a quadrilateral is 360 degree. Now we are not sure that it is a parallelogram. Okay. Now we don't know whether it is a parallelogram or not, but we are sure that it is a quadrilateral. So sum of angles will be 360 degree. Okay. 360 degree. Put the values of ABCD. So x plus 1 plus x plus y is 360 degree. 2 times x, 2 times y. So 2 whole x plus 1 is 360 degree. Okay. So we get x plus 1, 2 right side. Okay, dividing by 2 both sides, which is 180 degree. This is an important result which will help us to prove that it is a parallelogram. Okay. Now after this, in place of x you can put angle A. Okay. In place of x you can put angle A. In place of y you can put angle B is 180 degree. Okay. So angle A plus angle B is 180 degree. But angle A and angle B are allied angles or coincident angles. When allied angles are supplementary, the lines are parallel. Because when lines are parallel, allied angles are supplementary. So conversely, when allied angles are supplementary, lines must be parallel. So since angle and angle B, which are allied angles, you can see the diagram, which are the allied angles, they are supplementary. Therefore, we can say that AD parallel to BC. Why? Because allied angles are they are parallel. So we got AD parallel to BC. This is not sufficient. We have to prove now AB parallel to DC. Again check this equation 1. X plus y is 180 degree from equation 1. Okay, from equation 1. Now in place of x, let us take again angle A. But in place of y, let us take angle D. Angle D. So angle A plus angle D is 180 degree. But again we can see angle and angle D are right angles, okay, or coequal angles. If coequal angles are supplemented, the lines must be parallel containing the two angles. So AB must be parallel to DC. So this implies that AB parallel to DC. Same reason, allied angles are supplementary, okay? Allied angles are supplementary. So we proved that AD parallel to BC. This was not given, we proved now, okay? AD parallel to BC, also AB parallel to DC. So what type of parallel is this? Definitely this is a parallelogram. Okay, so after this you can write ABCD is a parallelogram, and you will give the reason. Opposite sides are parallel. So it is a parallelogram. So this is another method, another theorem, theorem number 3. Theorem number 3. Next, there is one more theorem for parallelogram only. Theorem number 4. Okay. First theorem was based on one pair of opposite sides. Second theorem was based on opposite sides are equal. Third theorem was based on opposite angles. Now we will move to diagonals. Okay, this is the last theorem. This is the last theorem for parallelogram. Okay. If diagonals of a quadrilateral bisect each other, it is a parallelogram. This is the last theorem based on parallelogram. Okay. So let us draw a quadrilateral in which the diagonals will be bisecting each other. This is A, B, C, D. You have to draw the diagonals. Nothing has been given about the sides. Simply diagonals. Let this point of intersection be O. It is given that OA is equal to OC and OB is equal to OD. This is given. Okay, and we are going to prove that it is a parallelogram. Given, look at the diagram. OA is equal to OC and OB is equal to OD. Okay. To prove ABCD is a parallelogram, okay. Now let us go to proof. Now we will use congruency here. We will prove congruency between these two triangles or these two triangles. Okay, you can choose any one pair. Suppose I am proving between these two, AOB and DOC. Okay, in triangle AOB and triangle COD. Look at the diagram. Okay, look at the diagram. AOB and COD. You can clearly see OA equal OC. This is given. OA equal OC. This is given. Next, angle AOB should be equal to angle COD. That means this angle must be equal to this angle. Vertically opposite angles. Okay. Vertically opposite angles. Okay. Next, OB is equal to OD. This is also given. Okay, given. So now we can get the order. AOB. Don't look at the diagram now. To get the order, do not look at the diagram. There will be confusion. AOB congruent to target angles if there are angles. There is one angle AOB, angle COD. So O middle, O middle. Ready? No more angles. Target sides OA, OC. Which vertex is opposite to OA in triangle AOB? OA means B. Which vertex is opposite to OC in triangle COD? OC means D. So B corresponds to D. So B last, D last. Okay. So which is the last option? C. Last option is C. Okay. So AOB congruent to COD in the proper order. This is SAS postulate. Okay. So this is the order of congruency. Once we get the order, we will get everything. Okay. I told in congruency. Now we can say. AB is equal to CP. Let it be equation 1. We got AB is equal to CD. We got one pair of opposite sides are equal. Okay, simply equal is not sufficient. There should be parallel also. For theorem 1, I am trying to use theorem 1 here. I am going to prove that AB is equal to CD and parallel also. So equal and parallel means it becomes parallelogram according to theorem 1. Okay. So simply equal is over. Now I go to prove that. Go for proving that AB is parallel to DC. Okay. For that I need angle OAB. OAB. Don't look at the diagram. Look at the order. OAB means 213. 213. So 213 means OCD. OCD by CPCT. So which are these two angles? OAB and OCD. OAB means this angle, and OCD means this angle. Okay, OAB, OCD. You can see, but you can clearly see in the diagram these two angles are alternate angles. They are forming Z set. That means alternate angles are equal. So lines must be parallel. AB must be parallel to DC. AB parallel to DC. Why? Because alternate angles are equal. Okay. So we got equal and parallel. Okay. See, we got AB equals CD. Look at equation 1. We got AB equals CD from equation 1. Then we got AB parallel to CD or DC. Second part. So equal and parallel. So it is a parallelogram. Okay. So now we can write ABCD is a parallelogram. Why? Because we have already proved that one pair of opposite sides are parallel and equal. Okay, hence proved. Okay, so this is theorem number 4. Okay, so these are the 4 theorems related to parallelogram, or how to prove that a quadrilateral is a parallelogram. First method is by definition. If you want to prove that a quadrilateral is a parallelogram, prove that opposite sides are parallel. Second is theorem number 1, means prove that one pair of opposite sides are parallel and equal, then it becomes a parallelogram. Third method or theorem number 2. Third method or theorem number 2 is prove that opposite sides are equal, it becomes a parallelogram. Fourth method or third theorem is prove that opposite angles are equal, it becomes a parallelogram. Then fifth method or the fourth theorem, the last theorem, is prove that the diagonals of a quadrilateral bisect each other, then it becomes a parallelogram. Okay, so I hope you have understood this part. Next we will move to theorems related to rectangle, then rhombus, then square. So it will be very long. This chapter is very big. Okay, so this is the end of part 3. I hope you have understood. Thank you for watching.